In this video, I'm going to show you how to evaluate limits at infinity of radical functions. So here we want to evaluate the limit as x approaches infinity of 6x over the square root of 4x squared plus 1. We see that the numerator and denominator are both increasing without bound, so it looks like we're going to have to manipulate this limit a little bit. Now think back to what we do in this situation when we have a rational function. For a rational function, we divide by the highest power of x in the denominator. Well, for radical functions, it's pretty similar, except the rule is that we factor out the highest power of x in the root. Let's go ahead and write that down here. So what's the highest power of x in the root? Well, it's the only power of x in this one. It's the x squared over here. So we'll go ahead and factor that out. So this becomes the limit as x approaches infinity, still 6x on top, but in the root, in the denominator, we write this as x squared, factoring out the x squared, times whatever we need to make it equivalent to the original expression. So x squared times 4 makes 4x squared, and then x squared times 1 over x squared makes the 1. And then we just write the limit again, separating out the product in the root, so it becomes a product of roots. So limit of 6x over, first we've got the square root of x squared, and then we've got the square root of all the other stuff, the 4 plus 1 over x squared. Okay, so now we want to go ahead and simplify that root x squared term. And we know that the root of x squared is just equal to the absolute value of x. Now here we have x approaching positive infinity, so that means x is greater than 0. And for x greater than 0, we know that the absolute value of x is just equal to x itself. The absolute value of a positive number doesn't change the number at all. Absolute value of 5 is 5, absolute value of 93 is 93. So for positive x, absolute value of x is just equal to x. And that means that for x greater than 0, we know that the square root of x squared, since that's equal to the absolute value of x, and absolute value of x is just equal to x, this is just equal to x. So that means we can just replace this root x squared with x in our limit. Let's write that in. So now this is the limit as x approaches infinity of 6x over root of x squared is just x. And then we have the rest of that root, 4 plus 1 over x squared in the denominator. Now, just to be very clear, whenever you have a root of x to some power and you want to simplify that, you do have to go through all these steps here. Because x is positive here, it turned out that root of x squared is just x. But when x is negative, that's a whole different story. We'll see that in the next example. But for now, just know that going from here to here is not as obvious as it seems. You actually have to work it out. Alright, so now we see something that we can simplify in our limit. This x here will cancel with this x in the numerator. So this is just the limit as x approaches infinity of 6 over root of 4 plus 1 over x squared. And hey, this is a limit that we can actually do, because we know that as x approaches infinity, 1 over x squared approaches 0. So this limit is just 6 over the square root of 4 plus 0. Square root of 4 plus 0 is just square root of 4, which is 2, and 6 over 2 is just 3. So there we go. There is the value of our limit. It's just 3. Alright, next example. We want to find the horizontal asymptote of the function f of x equals the square root of 9x to the 6th power plus x squared all over x to the 5th, where x is less than 0. Alright, so do you remember how to find a horizontal asymptote of the function? Well, that's just the limit as x approaches positive or negative infinity. And in this case, we're only considering a domain of x is less than 0, so we should take the case as x approaches negative infinity. So that's what we need to compute. We want to compute the limit as x approaches negative infinity of f of x. And f of x is just root of 9x to the 6th plus x squared all over x to the 5th. Alright, so do you remember what the first step is? The first step is to factor out the highest power of x in the root. So in the root, the highest power is x to the 6th. We want to factor that out. So this becomes the limit as x approaches negative infinity of factoring that x to the 6 out of the root. The first step is to factor it out of this expression inside the root. So x to the 6 times the leftovers, just 9 plus 1 over x to the 4th. Because x to the 6 divided by x to the 4th makes x squared. And this is all over x to the 5th still. Alright, so now we just go ahead and separate it from the root. Limit as x approaches negative infinity. Separate out that x to the 6th with its own root, square root of x to the 6th, times the square root of 9 plus 1 over x to the 4th. This is all over x to the 5th. And now we look at that term here, square root of x to the 6th, and we ask, can we simplify this? Why don't we just think about a simpler case first, just the square root of x squared. What would that simplify to in our situation here? Well, we notice that's just the absolute value of x, but when x is less than 0, what is absolute value of x equal to? It's not just x itself this time. For example, the absolute value of negative 5 is not still negative 5, it's positive 5. So you really have to flip the sign here, and the way you flip the sign is you tack on an extra negative here. So that negative will cancel out the existing negative sign on the x, giving a positive result. So that means when x is less than 0, we have that the square root of x squared is equal to the absolute value of x, which is equal to negative x. So the square root of x squared is equal to negative x. And now we can consider the square root of x to the 6th. So when x is less than 0, the square root of x to the 6th, well, just think that's like the square root of x squared times x squared times x squared, which is equal to the square root of x squared times the square root of x squared times the square root of x squared, which is equal to the square root of x squared to the 3rd power. Square root of x squared is just equal to negative x, as we saw before up here, and that to the 3rd power is equal to negative x cubed. The negative stays because negative 1 raised to the 3rd power is still negative 1. So now we can just go ahead and plug that back into the limit. So it's the limit as x approaches negative infinity of negative x cubed times the square root of 9 plus 1 over x to the 4th, all over x to the 5th. And we see that we can make some cancellations. So this x cubed can cancel with this x to the 5th in the denominator. This power 5 is reduced down to a power of 2. So writing this again, this is the limit as x approaches negative infinity of negative square root of 9 plus 1 over x to the 4th, all over x squared. And as x approaches negative infinity, we know that 1 over x to the 4th approaches 0. So this is just the limit as x approaches negative infinity of negative root of 9 plus 0 over x squared, which is equal to the limit as x approaches negative infinity of negative 3 over x squared. And we know that this limit, it's a limit as x approaches negative infinity of a reciprocal function. It's just a constant divided by an increasingly large denominator, so this is equal to 0. And that tells us that our horizontal asymptote is then y equals 0. That's the value that the function is approaching as x gets closer and closer to negative infinity. So now we know how to evaluate limits at infinity of radical functions. And in the future, we'll also learn how to evaluate infinite limits of radical functions.